I feel like I'm walking a bit into a Monty Python movie called And Now for Something Completely Different. So I'm going to go over a few topics relating to our experience in working with users that have internal HPC capacity and need to be able to use extra capacity to optimize how they're dealing with different user bases. I guess as a background, I'll start with a little bit about myself before I go into the meat of the presentation. So I grew up in HPC. When I was an undergraduate at CMU, I worked at the Pittsburgh Supercomputing Center on the CHARM projects. I then went to Cornell and worked at the Cornell Theory Center on the IBM SP2 that was there. So I have a bit of a background of large-scale SMP machines, or at least at the time that they were built. But in terms of the work that I've done, most recently, right before Cycle, wrote a software stack that managed a Disney movie production, which had number 84 on the top 500 list, including a data framework around the 70 terabytes of Blue Arc storage that we had, and this was in 2003 and 2004. So I'm not coming at this as a cloud guy, I'm coming at this as an HPC user, and hopefully you'll be educated by some of what we're going to go over today. I'm not really going to cover our products in tremendous detail. My goal is to go over beliefs and lessons learned. So from a practical standpoint, the way I look at this, cloud is really about increasing access, and our fundamental belief is that the more you increase access to computing, the faster we as a society will invent. It's a direct correlation. The more you plug in users to computational capabilities, the faster we invent. There's no two ways about it. That's why everybody at Cycle does what we do, and that's what gets us up in the morning. Our belief around this, though, is that cloud is a way to increase access, both in terms of time to acquire resources and in lowering the barrier to entry to get access to basic systems. So for us, the mission is to create software that enables clouds to be productive at any scale for organizations that have many users and many workloads that they're managing. And some of those absolutely need to be running internally and will not go externally, but you need to be able to handle the other use cases. So since doing this, we started in 2007 doing this work. It's going on 9 years right now, and we've learned a lot of things directly through users. So I'm going to speak in the context of real-world use cases, even though a good number of the companies that we generally deal with won't talk. All of these guys have actually talked publicly. There's like one example of an anonymized use case that's not public. So if you have any questions about any of these, feel free to interject. I know I started a bit late. Hopefully I can end a little bit late. We should be okay on time. Lesson one is really to think about cloud as just a tool in your tool chain. So this is not a different way of doing exactly what you're doing today. This is a new capability that allows you to do things you couldn't do before. And more particularly, the way to think about it is about getting the easy workloads off the hardware that really is meant for the hard workloads. So when you want to provide access to users that are running workloads that are throughput oriented, for example, and not taking advantage of the interconnect, you actually want to get the people that can use the bus out of the way of the people that need to use the Maserati. So on this type of workload management, we find for customers that have a large number of users and a large number of applications, cloud is an excellent way to augment your internal capability and make it so you can service a broader user base. As an example, J&J has some computer-aided manufacturing workloads that they run on internal kit. It has InfiniBand. It is specifically designed to run those workloads. From a practical standpoint, they have a number of other workloads like clinical trial simulation, which they actually burst out into the AWS cloud. So this slide from J&J came from an AWS reInvent talk that they gave not too long ago. And fundamentally what they're trying to address is the classic cluster problem, which is when you have a large number of users, your fixed size cluster is too small when you need it most, and it's too large when it's not being utilized. So their goal is essentially to enable the fast workloads to run on the fast interconnect and enable the throughput workloads to run externally. And so they essentially set up a system to do this. Another example is capability that you would not have internally at scale. So again, customer has 500 servers internally, InfiniBand connected, they're completely used. Their queue wait time at this point was 2+ weeks. If they carved off a portion of that cluster to operate this workload, it was estimated at a 6-month, 180-day completion time. So instead, we essentially orchestrated the data across their internal environment out to external multi-region AWS, ran 10,000 servers worth of infrastructure, so this is 80,000 cores thereabouts, essentially turned around the results, again, encrypting the data in the process with keys that only the pharmaceutical in this case had, and completed about 40 years of computing, so 341,000 hours in 9 hours, and the total cost on this in spot instances was $4,300. So this is a throughput workload. It's not taking advantage of InfiniBand. It makes no sense to move someone who's using this off in order to run this, especially at that price point. Lesson 2, it's not one public cloud, there's now a few of them, and they move quickly. So AWS has moved the fastest over the last 10 years. They created the category. They've continued to add newer and newer capabilities into the infrastructure that they provide, but you now have differentiation. So Microsoft has InfiniBand available. Google's got very interesting cost control and cost optimization with some exceptionally reliable infrastructure. And all of these guys are updating the SKUs that they have multiple times a year. So you see Intel delivering a custom chip for AWS that's designed to run compute-intensive workloads. These things are unique differentiators that you generally don't get in an individual site. And from a practical standpoint, what you want to do is enable users to be able to map the applications they have to the environment that's going to run it fastest or the environment that's going to run it cheapest very easily. And this is something that you must consider from day one, is how am I going to take advantage of the differentiated infrastructure that's available? Because there's a fixed number of SKUs out there in cloud. You can benchmark at any given point in time across all of them and be able to determine where you should be running your workload. But this is a moving target. Because they're all constantly rolling out new infrastructure, this is something that, practically speaking, changes month to month. So if you have 3 different providers, each doing about 2 updates every 2 months, on average, you're getting a different kind of infrastructure that's available for your user base. Sometimes it's a new GPU, sometimes it's something that has a better RAM ratio for a particular type of workload. These kind of cost efficiency changes happen all the time and are important to be able to manage. So as an example, HGST, which is a maker of a lot of the server hard disk drives that are available inside of the cloud providers themselves and in most of the laptops that I currently own. They have multiple applications that they want to be able to manage across different providers, understanding where the map is so they can either get the cheapest result or they can get the fastest result depending on what they need at that time. And again, this is always in the context of augmenting your internal workloads as well. So if you do this properly, in their case, they've seen 6 to 90x throughput for various of the applications that they've managed and a 2x productivity increase. So their engineers are able to design hard drives twice as fast because of dynamic access to capacity. The important thing about that is you need to then consider having tools that allow you to interact and understand the performance characteristics of both the instance types on the compute side, and you also need to understand how you're managing your data, because both of those environments are important relative to running multi-cloud successfully. Lesson 3 is getting servers in minutes is great, but where does that really help you? Like, where is it that that actually matters? So there's kind of 2 main use cases for this. Number 1, you can't fit the question you want to ask inside the infrastructure you were able to buy a year ago. So instead, it's better to create the infrastructure to ask the question, to answer the question. I gave an example earlier of a 10,000 server workload. This is another one. This is a Fortune 50 insurance company. They run a 2,500 core internal production cluster and essentially are operating about 10,000 cores in AWS cloud externally. They run about 25 years of computing through that on any given individual day within the week, and it doesn't make sense sense to buy 10,000 cores for a 1 day a week workload. This is running now currently, and again, this is the upgrade path. They started off on C3s, and then C4s are what they're using currently. So they've got 10,000 Haswell cores that they basically expand out to and be able to augment their internal capacity. So these are the kinds of use cases we see over and over again. We ran a very large workload, 156,000 cores. We spun up, when we did the test run before this, we did 125,000, and that spun up, I believe, in 24 minutes on external environments. So imagine installing a 156,000 core cluster. This one was about 35 to 40 minutes in a 35 to 40 minute time frame. The user was basically able to run, again, a high throughput workload. So there was about 1.21 petaflops, and this is again an ARP peak. It's a theoretical peak, not an interconnect oriented workload. This was a quarter of a compute millennium. 264 years of computing done on behalf of a researcher at USC that was looking for better solar materials. They had large quantum chemistry workload that they were running to determine how efficient a given solar material was. They ran it across all 8 public regions. Our software makes this kind of workload possible and straightforward to operate. The other kind of workload where getting access to servers fast matters is in specialized workloads, places where you have specialty OSs. I know when I was working at the movie, I had customers in crowds that liked one stack and customers in VFX that liked a different stack. I don't know how many of you have had to deal with that when you have customer codes that aren't friendly towards each other, or you have workloads that aren't friendly towards the RAM CPU ratio that you bought 2 years ago when you bought the cluster. So from a practical standpoint, being able to augment internal capacity with these kinds of dynamic capabilities is really important. Normally inside of the stack for a cluster, you have a number of different considerations, everything from, where you're going to run this, through what file system are you going to use, how are you dealing with security, any encryption, any OS deployment, app deployment, and there are a number of different tools that you can use. I know Bright's here today. They do a great job of getting things on the clusters. These kinds of choices are things that you have to do on internal infrastructure. What we try to do is make it so you can use the exact same tool chain externally, and if you go to do this yourself, you want to do this. Make your environments consistent so you can add essentially new nodes that either have a different OS because that's what's needed for this part of the stack, but the rest of your tool chain is all pluggable and entirely consistent between internal and external capacity. An example of this is NASA Goddard. So they essentially ran a large-scale satellite image processing workload, and in the interest of time, I'm not going to go into tremendous detail, but we essentially got a workflow set up that grabbed the data as it was coming off of the public data set in the satellite, put that into AWS Cloud, processed it, turn around, put the results back internally, and the reason they wanted to do that is they had no internal capacity, and the workload itself required a hardware profile that they didn't have to begin with. So ordering this process would have taken longer than the deadline they had to run the compute anyway. So another constant example of this is Hadoop. You have Spark, you have Cassandra. These are things that require different things than HPC use cases require. We had Ion Reporter, which is a Life Technologies multi-user SaaS application that we operate. Essentially for this workload, we ran Hadoop. They decided a year in to instead change that to a batch environment. So they actually changed out the scheduling environment and were able to change out the profile of the nodes without having to change their code, without having to redeploy. All of that was handled because cloud gives you the flexibility to do this kind of thing. So lesson 4, when you're thinking about internal infrastructure, you're making big technology bets on, where is the future going to go in terms of what my code should be aligned with, what data center space, cooling, power considerations and constraints do I have. When you deal with external cloud, you're focused on 2 things. How much does it cost to get your answer and how fast can you get it back? Those are the only 2 generally the only two considerations that you're really worried about. Security is obviously a must, and the only reason I'm not covering that, frankly, is I put J&J, a Fortune 50 insurance company. There are a lot of people that have regulatory workloads. We have people with ITAR workloads that run things externally. If you do have concerns around security, please come back to our table and talk to us about it. But this is obviously a must. So in terms of being able to focus on time to result or cost, we have a customer, the Broad Institute. They run large-scale machine learning workloads to analyze the difference between different data sets that they have and how they're interrelated. They basically create a map of which data sets are related to which others. Essentially, in this case, they had been running on AWS. They had essentially a workload that when they benchmarked it actually worked better for this particular use case on Google. So they ran 50,000 cores using the same template on GCP instead of running it on AWS for this instance. So from a practical standpoint, it was again, a production workload. It ran 3 decades of computing in 6 hours. The total bill was in the $4,000 range. So from a flexibility standpoint, what you want to be able to do is accommodate large workloads and think about them in terms of, am I going to get the cheapest dollar amount or am I going to get the fastest result? All other considerations are really held by the cloud provider. Another example of this, again, optimizing for cost. This one ran on AWS. It's a 70,000 core workload doing 1 million different head designs for HGST. They ran on 70,000 processors. They had 200 plus cores in-house, so this workload would have taken an exceptionally long period of time to run otherwise, and instead they got about 9 hours on the response time. The total cost was in the $9,000 range, and again, this is a classic example of being able to get the school bus out of the way of the Maserati. They instead used the internal cores for things that would matter. Last, but definitely not least, this is the high order bit, is this really gives you an opportunity to help your user bases be able to leverage a different workload. Now I'm going to steal 2 slides from a CIO that gave a talk about a project that we did with them. They had a workflow internally with their engineers where they essentially did about a month of computing. They did about a month of analysis. Then they did about a month of computing. Then they did about a month of analysis. So their iteration time was a 2-month iteration time. When they went to cloud, they anticipated that they would basically shrink the computing portion of this. So they'd be able to go to an 8-hour compute time and still do a month worth of analysis. But what they actually discovered is that when you context switch like that, when you have a queue wait that's more than a few hours and you're waiting to get your result back, and then you have to think, okay, now what was it that I submitted? What was I trying to get out of this? Great, now let's analyze it, et cetera. That really slows people down. It's incredibly slowing. So from a practical standpoint, they actually got a significant speed up where they did a day of computing and 2 days of analysis, a day of computing, 2 days of analysis, simply because they didn't have to find their place again as a workflow. So embracing this kind of transformation for workloads that actually support it is a tremendously valuable in terms of accelerating the answer, and what that means is you're then accelerating your people. So this applies to all of these various forms of workload, batch simulation, small-scale MPI, through life sciences, through financial services. We have energy, we have electronics and semiconductor companies. There's all kinds of big data use cases that obviously fall into the throughput category. These are a wide range of different workloads you can use to enable different users. Our software, and this is my one product slide, basically has the full life cycle management of these workflows on cloud, and we help admins be able to manage multiple users running multiple different types of workloads within their organization with cost controls and compliance and security and what have you. So this is the area that we focus on primarily, and if you're interested in this, if you have a desire or a need to be able to enable external capacity to augment what you have internally, then please stop back at the booth or email me personally at jstowe@cyclecomputing.com. And that's all I got. So I hope I have a moment. I ran through that. Do we have a minute for questions? Awesome, great. Questions? That was exceptionally dense, I'm sorry. Okay, great. And now for something completely different.